Okay, so hello everyone. In this section, what I want to focus on is section 1.3 of this, basically of, this, how do I say it? Of Precalculus. So give me 1 second, guys. Okay, so, alright. So, in the last section, what we just looked at radicals and exponents. Now, in this section, we want to look at algebraic expressions, specifically adding and subtracting polynomials. That's part 1. Multiplying algebraic expressions, special product formulas, factoring common factors, factoring trinomials, special factoring formulas, and factoring by grouping terms. So I'm just going to go ahead and very briefly explain everything that we have studied in the past. So obviously we know what a variable is. A variable is any letter that they give us where it is a type of formula. So like x, y, and z, and we can combine them, we can make equations out of them using addition, subtraction, multiplication, and division, and also roots. And whenever it's not a function, this part of so like for example, 2x squared minus 3x plus 4 is an expression. The square root of x plus 10 is an expression, and y minus 2z over y squared plus 4 is also an expression. Now, a monomial is an expression, so basically you have any expression of the form ax to the n, so this is a monomial, where a is any real number, and n is any real number, and x is the independent variable, right? So that's what a monomial is. A binomial is any equation or expression, basically, yeah, expression. It can be algebraic, or it can be any, like, any type of equation, and that has two terms. So you have, for example, ax plus b, or basically it's the sum of two monomials, right? So if I say, for example, ax to the n plus by to the n to the, actually I'll say to the x, or actually to the p. So this is a binomial, right? A polynomial is an expression with more than two terms, or rather, let's see here. Well, a trinomial is a sum of three monomials, and in general, any sum of any monomials is a polynomial. So this can be a polynomial, basically, this can be a polynomial, and this can be a polynomial. But actually, I don't think this can be a polynomial, unless it was of the form x to the 1/2, then I believe it is. But since this is a square root function, I don't think it's a polynomial. I'll have to double check, but also this one, this cannot be a polynomial because it is a rational function, but it is, all of these are algebraic expressions. Now, it says a polynomial in the variable x is an expression of the form ax to the, or a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1 x plus a sub 0. So, don't get confused by this. This is just the general form of any polynomial. You don't have to remember how this is, okay? It just tells you that any polynomial can be written of this form, where a naught, a sub 1, and a sub n are all real numbers. So this can be any real number, this can be any real number, and n has to be a non-negative integer, so it has to be positive. And then, so yeah, I mean, you don't really have to, don't overthink this. It's not that complicated. It's just saying that we can add any degree n. It can be of any degree n, and it has to be of descending exponents or descending degrees. Now, this, so it says, note that the degree of the polynomial is the highest power of the variable that appears in the polynomial. So that's what I'm saying, is that it has to start with the highest degree. So for example, the polynomial 2x squared minus 3x plus 4, the type of polynomial is a trinomial, and the terms are 2x squared, negative 3x, and positive 4. And the degree is 2 because the highest degree is 2. The polynomial x to the 8th plus 5x, that's a binomial, and the terms are x to the 8th and 5x, and the highest degree is 8 because right here it starts with an 8. It's the highest degree. And then it says 8 minus x plus x squared minus 1/2 x cubed. This is a 4-term binomial, or a 4-term polynomial. The terms are negative 1/2 x cubed, x squared, negative x, and 3. And the degree is 3. Notice that this one is not written in order. In reality, the polynomial would have to be written as negative 1/2 x cubed plus x squared minus x plus 8. So in reality, when they ask you something like this in an exam and they're like, well, is this a, or what is the highest degree of this polynomial? It would be 3. And this would be a 3rd degree polynomial, okay? Because just because it's at the end, it doesn't mean that 8, or just because just because 8 is in the front doesn't mean that it's the highest degree is 0, or it is a 0 degree term. You always look at the highest, the little number here, you always look at the highest one. Now, 5x plus 1, the polynomial, 5x plus 1, this is a binomial because it has 2 terms, 5x and 1. And the degree is 1 because it's x to the 1st power, which is just x. Now, 9x to the 5th, that's a monomial because it's just 1 term, and it's and the terms are 9x to the 5th, and it's a degree of 5. And 6 is a monomial. The terms are 6, and the degree is 0 because if you think about it, 6x to the 0 is just 6 times 1, which is just 6, okay? So it's with a 0 degree polynomial, or 0 degree, it's with 0 degrees, basically. Okay, it says adding and subtracting polynomials. It says we add and subtract polynomials using like properties of real numbers that were discussed in section 1.1. So, in reality, it's like I said, and of course, this is something that, yes, you did learn in algebra. When we have any, so basically these are 2 monomials. This, we can say that this is a polynomial, or actually a binomial of degree 7, it's a binomial because it has two terms. So then anytime you have the same degree and you have the same variable, you just add them. 5x to the 7th plus 2x to the 7th is 7x to the 7th, right? That's what that's saying. Now, they did do it in a different way, and I know it's a 3, but it's the same idea. They did do it a different way. They said, well, x to the 7th times 5 plus 3, or 5 plus 2, excuse me, is equal to, and they said, well, it's, and they said, well, it's distributive properties, so it's really x to the 7th, or actually, no, they said x to the 7th, and they said 5 plus 2 is 7, so in reality, it's just 7x to the 7th. That's just another way of adding it. But anytime you have the same variable and the same degree, you want to go ahead and add those when they're being added or subtracted. Okay. Now, it says in subtracting polynomials, we have to remember that if a minus sign precedes an expression in parentheses, then the sign of every term within the parentheses is changed when we remove the parentheses. So that all of that is saying is that negative the quantity a plus b is just negative a minus b. Similarly, if a plus b, so if a plus b equals 1, that means that negative the quantity 1 is just negative 1. If I say that negative 2 plus 3, so basically if I'm given this expression, I can say that this is negative 2 minus 3, which is negative 5. Or I can add the inside and just distribute in the negative after, which is negative 5, right? I'll get the same exact thing. That's what all of this is saying. And this is a very special rule, because obviously we basically, it's distributive property. That's something that you time and time again in your future math classes will use so much, and it's so important to understand how it is, right? All right. So let's go over a few examples of adding and subtracting polynomials. We add and subtract polynomials to understand, like, basically we have to know how to add and subtract polynomials. That's just how things are, You do this with, you do this a lot in calculus, you do this a lot in trig as well. It's just one of those basic things. It's like, having to solve a linear equation. You have to know how to add and subtract polynomials. All right, so let's just go over this first one, even though I know you probably saw the solution already. We have, find the sum of this expression. It says x cubed minus 6x squared plus 2x plus 4 minus, plus x cubed, and then it says plus 5x squared minus 7x. Right? Now, one of the things that, and I do believe, yes, we learned these in college algebra, but this is much faster now. We're just gonna go over this example, okay? And if you don't know how to do these, I do have a video explaining how to do this in my YouTube channel. Like, I go over a lot of examples, but anyways, the way you do this is, all you have to do is you have to say x cubed, and then you have to combine everything, basically. X cubed, and then you say plus x cubed, so as you go along you can cross it out, and then minus 6x squared, and then you look at your other one. What is your other one? 5x squared, right? Plus 5x squared, cross them out, plus 2x, cross it out, and then minus 7x, cross it out, and then what's left over? A positive 4, right? And don't get confused by this addition. It's just saying, it's literally just saying x cubed minus 6x squared plus 2x plus 4 plus x cubed plus 5x squared minus 7x. It's the same thing. You don't have to really put parentheses, but that's exactly what we have here. I just have it in order of descending exponents. It's always recommended that you add in order of descending exponents, the little numbers here, because that way it can make your work look much cleaner. So x cubed plus x cubed, that's just 2x cubed, negative 6x squared plus 5x squared, that's negative x squared. And then 2x minus 7x, that's just negative 5x. And then we have a positive 4 left over. So our answer to this one is 2x cubed minus x squared minus 5x plus 4. Okay. So you see how right here they got the exact same answer. Now, there's a difference. So there's a huge, there's, and it's pretty funny because we're finding the difference. But anyways, there's a huge, like, how do I say it? These two are very different in the way that when you're finding the difference of two polynomials, you always want to make sure that if it is in parentheses, you distribute this negative into the parentheses, because if you don't, you're going to get the answer wrong. So let's just look at this one. So it says x cubed, and let me go ahead and write it really quick. Okay, so now this one is a little more different. So it's the same problem that we had, but now we're subtracting. So what we're going to do, so the first expression that's in parentheses, yes, go ahead and bring it down. It's okay to do that. However, this expression, specifically this minus expression, what you're going to do is you're going to go ahead and distribute the negative in, right? So we do that, and we get minus x cubed minus 5x squared plus 7x. Now, so now we can go ahead and rewrite this in order of descending exponents. X cubed, and then we have a minus x cubed, and then we have a negative 6x squared. So let's cross out as we go along. And then we have a minus 5x squared, right? And then a plus 2x, and then a plus 7x, and then a plus 4 right here, okay? So then we have x cubed minus x cubed, that's 0. We have a negative 6x squared minus 5x squared, that's negative 11x squared. And then a 2x plus 7x, that's a plus 9x. And then we have a plus 4 left over. Now, notice that there's a 0 minus 11x squared plus 9x plus 4. So now you can just say this is equal to negative 11x squared plus 9x plus 4. Okay. All right. Okay, so now multiplying algebraic expressions, right? If we look at let's look at example 3, right? Let's look at example 3. So multiplying polynomials. So it says when we multiply trinomials or other polynomials with more terms, we use the distributive property. It is also helpful to arrange our work in table form. The next example illustrates both methods. So this one, I'm going to use I'm going to do it using distributive property, okay? So there's a way to do this, and you don't have to use FOIL method for this. So, I mean, I wouldn't, if FOIL method is something you don't like to do, that's okay. Minus 5x plus 4. Right? So if FOIL method is something you don't like to do, that's okay. We can do the following. So anytime we have any two numbers, so let's say we have something, so let me go ahead and write this down very quickly. So anytime we have something like this, we don't have to use FOIL method if we do not want to. All FOIL method says is it's another way to help make it easier, but it can be confusing, right? Because you would have something like this, and then like this, and like this, and then you have something like this, this, this. So it can be very confusing, and sometimes you can get a little lost, right? But try to just think about it as you're multiplying every term to every term. If you grab A, you're going to multiply it to this whole thing, right? That's like if I said 2 times 3 plus 1 plus 5, right? Well, I'm multiplying it to 3 plus 2 times 1 plus 2 times 5, right? That's if you know distributive property. You're doing the exact same thing here. So you're just going to say A times C plus D plus G, right? So you're going to say A, so it's going to be AC plus AD plus AG, right? But also, notice that the B is also involved here. Plus B times plus B times C plus D plus G, right? So then we have times C. So basically, we would go ahead and do distributive property here, right? We would say BC plus BD plus BG, right? And this is all this is saying, right? So looking at this function here, looking at this product here, we have 2x times x squared plus 2x times negative 5x plus 2x times 4. And then let me go ahead and okay, so then we have, so it's 2x times plus 2x times 4, and then we can go ahead and put brackets on this, right? Plus 3 times x squared minus 5x plus 4. In reality, we can say that this is equal to 2x times x squared minus 5x plus 4 plus 3 times x squared minus 5x plus 4, right? So this is a lot easier than than doing FOIL method, right? All you have to do is plug it, is multiply it out. So you have 2x cubed minus 10x squared plus 8x plus 3x squared minus 15x plus 12. So then you combine like terms, right? So then you only have one 2x cubed, or 1x cubed term. The other ones would be negative 10x squared and negative 3x squared, and then another one would be 8x and negative 15x, and then you are just left over with what is it called? With a 12, right? So really this is just 2x cubed minus 7x squared minus 7x plus 12, right? So that's a good way of looking at it. Now, there's also table form, but in reality, with table form, it's a little harder. It's just like how you do, like, when you multiply numbers. When you do something like this, and you do like this, but that's a little harder. Now, if you do not like using that form, there's one more way which we can do this, right? And I like to call this the box method. You would put 2x and positive 3 here, and then you would put x squared minus 5x plus 4 here, right? So in reality, 2x times x squared, that's 2x cubed. 2x times negative 5x is negative 10x squared. 2x times 4 is 8x. 3 times x squared is 3x squared. 3 times negative 5x is negative 15x, and then 3 times 4 is 12. So you would say 2x cubed minus 10x squared plus 8x plus 3x squared minus 15x plus 12. You would go ahead and just add in everything that's inside the box, right? If it depends on whether it's positive or negative. So then you would say this is 2x cubed, and then you have negative 10x squared and 3x squared, right? That would be negative 7x squared, 8x and negative 15x. That's negative 7x, and then you just have a positive 12 left over, right? So, that's how you would do it. And this is honestly, in my own opinion, when it comes to harder polynomials to multiply, I like to use this method with the box method, because sometimes when you do something like this, it becomes very hectic. And not that I cannot do that, but I mean I can, but it just takes a lot longer, right? So that's why they introduced this box method to also do it. Okay, so these are some special product formulas. This is the sum and difference formula, which we've learned before. A plus b times a minus b is a squared minus b squared. And then it says a plus b quantity squared is a squared plus 2ab plus b squared. So the first one is sum and difference of same terms. So this is a sum and difference pattern. The second one is called the square of a term, or the square of a sum of two terms, so a plus b quantity squared. And then the third one says a minus b quantity squared is a squared minus 2ab plus b squared. That's the square of a difference. And then number 4, which I still have somewhat of trouble remembering that one, I'll be honest, is the cube of a sum, which is a cubed plus 3a squared b plus 3ab squared plus b cubed. And then the cube of a difference is a minus b quantity cubed, and it's a cubed minus 3a squared b plus 3ab squared minus b cubed. Okay. Now, this is just explaining how this would tie into a product of two terms, right? So you would say x, so basically it's a squared plus 2 times a times b plus b squared, right? So it's x squared quantity squared plus 2 times x squared times y cubed plus y cubed quantity squared. And that's what this is saying. All right. Now I'm going to do one example with this formula. So again, if you don't remember, and yes, I'll be honest, I don't remember exactly how to multiply a cube of basically, so when it's a cube term or a sum of or a product of two cubes. So basically here, it's x minus 2 squared times x minus 2, right? So let me say, so obviously I do remember off the top of my head how to do a square of, or a product of two squares, right? So, and if you don't remember, it's just x minus 2 times x minus 2. If you don't like multiplying that out, you can say x minus 2, x minus 2. So this is x squared, negative 2x, and positive 4. So it's x squared minus 2x plus 4. So that's x squared minus 4x plus 4. Me being the way that I am already, obviously I knew that already, just like I know that x minus 3 squared is equal to x squared minus 6x plus 9, and we know that because, of course, it'd be x squared, negative 3x, and positive 9, so then we have x squared minus 3x plus 9, x squared minus 6x plus 9. So, yes, I do remember that. But if you don't remember how to do it, you can always use the box method, and it's okay. Now, then we have to multiply it to the monomial here, or the binomial here, a trinomial with a binomial. Now, if you don't like to do FOIL method, like I explained in the previous example, if you don't like to do this way, basically, if you don't like to do it this way, then that's fine. I mean, I don't think that there's an exact way to do this. Obviously, you know, whatever way you want to choose is okay. Some professors do want you to use FOIL method. Others are okay with whatever you use. It is good to know how to do it using FOIL method, though. Like by doing it both ways, it's a lot better because you at least understand and you can know the difference between doing it by box method and by FOIL method. But at least I don't think you have to do it by either way as long as you actually multiply it. So obviously, we can do x minus 2 and x minus 2. This is x squared, negative 2x, and positive 4. We have x squared minus 2x plus 4. So times x minus 2. So now we can go ahead and use the box method again. So we have x squared minus 4x plus 4 times x minus 2. And again, if you know the difference of two squares, or the sum of or the difference of a perfect cube, that's great. That's great because that you can automatically just know how that is, and you can write it down and you can just apply that rule to this formula here. But for some of us, like myself, I will admit, we have to use the box rule. or FOIL method. So, let me add a third box here. So if I do x squared minus 4x plus 4, and then I do x minus 2, I say, okay, what's x squared times x? That's x cubed. Negative 4x times x, that's negative 4x squared. Is a plus. 4 times x is 4x, and then x squared times negative 2 is negative 2x squared. Negative 4x times negative 2 is positive 8x, and then 4 times negative 2 is negative 8, right? So then we have x cubed minus 4x squared plus 4x minus 2x squared plus 8x minus 8. And then we combine like terms, so we have an x cubed, we have negative 4x squared and negative 2x squared. That's negative 6x squared. And then we have 4x and 8x, so that's positive 12x, and then we have a negative 8 left over, right? So this would be my answer. Now, oh, and by the way, it was x squared minus 2 cubed. I didn't see that. But it would be almost the same thing, because it's the same terms, it's the same leading coefficients, it's just different degrees. But yeah, I mean, if you have x squared quantity cubed, of course it'd be x to the 6, and then minus 3x squared quantity squared times 2, and then plus 3x squared times 2 squared minus 2 cubed. So they're just applying these special product formulas for this one. All right. So this one, so let's do A. Let's do A because I want to explain how they did this one really quick. So 2x minus the square root of y times 2x plus the square root of y. This is 4x squared plus 2x square root y, and then minus 2x square root y minus the square root of y quantity squared, right? So it's 4x squared, and then these two cancel out, and the square root of y quantity squared is just minus y, right? So if you do this using box method, you would have 2x minus square root y, and then 2x plus square root y. And you would say 2x times 2x is 4x squared, right? Two x times the square root of y is 2x square root y, and then 2x times negative square root y is negative 2x square root y, and then you would say the square root of y, so it'd be minus the square root of y quantity squared, which is just minus y, really. That's how it would be. And then you would say this is just 4x squared minus, or plus 2x square root y minus 2x square root y minus y, right? So it's 4x squared minus y. So you see how I got the same answer for both of these using FOIL method and box method. Like I said, there's no, like, unless your professor tells you or your teacher tells you, there's no right way to do this, or there's no one way to do this. You can do this either of these ways, right? And I could have also used the sum of two squares pattern, right? Or the sum and difference pattern, a plus b times a minus b, given that a is equal to 2x and b is equal to the square root of y. So in reality, I could have used that rule. And I could have just said, oh, this is just 2x quantity squared minus the square root of y quantity squared, and it's 4x squared minus y. So really, there's no one way to do this. You can do it any way that your heart desires. Okay. So yeah, like I said, substituting a and b, and they used the product formulas to do this, and they got 4x squared minus y, right? And then part B, they said, well, they used grouping, but like I said, there is no right way to do this. You don't have to do it any special way. X plus y minus 1 times x plus y plus 1, right? Now, they went ahead and used the sum and difference pattern. They said that a equals x plus y, and b is equal to 1. So then they said a plus b, or rather, a minus b times a plus b, and they said a squared minus b squared. They said x plus y quantity squared minus 1 squared, right? And then they said, okay, this is really just x squared plus 2 times x times y plus y squared minus 1. So then they said x squared plus 2xy plus y squared minus 1. But again, that's how they did it. But again, the reason why they teach you this kind of stuff is so that you can get accustomed to think in this way rather than, so that way you're better prepared for ones that are not that easy to do, right? And they want you to try to actually remember these patterns. And again, it's not, like I said, it's not really like, you can do it whatever way that you want. It really is not that serious, but it would be good, and it would help you a lot in your future math courses if you try to remember, the sum of two squares pattern, and also the square method and FOIL method, because that, if you remember a lot of those, then you are really, you'll be good in calculus. You'll be great, because it'll just help you a lot. And that is why we're going over this, because in Precalculus, they want you to make sure that you are prepared enough for calculus to understand these basics, because these occur a lot in Calculus 1 and 2. So, let's see. And then they talk about factoring, right? Factoring common factors. So it says factor out each expression. So part A, so this is example 6, right? Part A says to factor 3x squared minus 6x, right? Now, if you see a common factor between the both, so if I look at these and I say, okay, what is common between these two? Well, they have an x, and I know that they're both divisible by 3, right? Because 3 over 3 is equal to 1, and 6 over 3 equals 2. Or rather, negative 6 over 3 equals negative 2. But they're both divisible by 3. So if I think about it, I can say, well, this is equal to x times x times, rather, 3x minus 6, right? And I can put this, I can color code this really quick so that you guys can understand what I'm saying. right? And then I can say, well, this is equal to x times 3 times the quantity x minus 2, right? And what is this all equal to? Well, this is equal to 3x times x minus 2. And this would be the final answer factored. Okay. Now, there's this one also. This is a little bit more complicated, but it's okay because, again, they want to prepare you, and that's why this, in Precalculus, they go from very simple algebra, and it gets tougher, but at a lot more, it's at a bigger, at a faster pace, because because obviously we've already seen these in college algebra, so they want to train you to look at these more quickly, right? So part B says factoring 8x squared 8x to the 4th y squared, and then plus 6x cubed y cubed, and then minus 2xy to the 4th, right? Oops. So this one says, well, if we look at, again, you have to ask yourself, what can I factor between the 3 of these? And if it helps, you can do the factor tree for these numbers, right? If that really does help you. Now remember that you never want to include 1 in 8 or 1 in a number, because obviously we know that, you know. You want to know, okay, is it divisible by 2? Well, yes, it's 2 times 4. Divisible by 3? No. Divisible by 4? Yes, but we already have 4 times 2. Divisible by 5? No. Divisible by 6? No. Divisible by 7? No. So, and again, 1 in 8 is the same as 8 in 1, so I don't really want that, right? And then I go over here and I say, well, 6. Well, there's 1 in 6, and obviously anything multiplied by, or 1 multiplied by any number is the number. So I can say, well, basically what I mean by that is like 1 times n is n, which is just n equals n. That's what I mean by that. If I say a times n, or a times n, that's just an. Or a times b, that's just ab. Anything, right? So then I look at I look at 6, right? And I say, okay, well, there's 2 times 3. And then I look at -2, and I'm like, well, there's just, all there is with this one is -2 and 1. But, or I can say 2 and -1, right? So that way I have a +2 on all of them. So then I can say, well, all of these are divisible by 2. So then when you divide them, I say, okay, well, it's 4 x to the 4th y squared, because 8 over 2 is 4, plus 3x cubed y cubed minus x y to the 4th, right? And then I look at it and I see, okay, well, there's an x and a y common, right? I can say that. I say, well, there's, you see, and again, when you divide by something, you have to go ahead and put it on the outside of the parentheses. You always want to remember that. Anytime you divide a polynomial like this over a number, you want to arrange it so that the number that you divide by is outside the parentheses when you're factoring, okay? So then I say, okay, well, there's an x and a y value, so x and y are common, so I can say, well, this can be divided by xy. If I do that, I can say, well, 2xy is equal to, so it's going to be 2xy times, and I say, okay, well, there's 4, and then to get x to the 4th, I multiply, and I say, well, it's going to be times 4x cubed, and then y squared, to get from 2xy to y squared, I just go ahead and put a y here. And then plus, and then I say 2x, and then I say, basically, I would say 3, and then it would be x, since this is x cubed over x. So basically, if I say that, I can say, well, xy, that's just x squared, right? X squared and then y squared, right? Because if I say xy times x squared y squared, that's going to give me x cubed y cubed. So 3xy would be the answer to that one. You have to kind of, if it helps, you can say the following. So if it helps, instead of doing this, we can say the following. 4x to the 4th y squared over xy plus 3x cubed y cubed over xy minus xy squared over xy, right? This is all multiplied by 2. And I can use the laws of exponents. 4 minus 1 is just 3, so I can say 2 times 4x cubed y plus and whatever number that I divide by. So basically, I can say the following, like this, right? 2 times 4x cubed y plus 3x squared y squared, and then minus x, or rather, since this x cancels out, I can just say minus y, right? And since I multiplied, or divided by xy, I can multiply it back in, right? But not into the parentheses, but outside. So I can say that this can be 2 times xy times 4x cubed y plus 3x squared y squared minus y. I know that I'm taking long on this, guys. I understand, but it's very important that we remember how to do this, because I know that, well, yes, it's just really important to remember how to do this. So then I say 2xy times 4x cubed y plus 3x squared minus y. So basically, now we can go ahead and factor out a y, right? So that means we have 2xy times y times 4x cubed, we're going to take the y out, plus 3x squared y minus 1, right? And this gives me 2xy squared times 4x cubed plus 3x squared y minus 1. And I can use the Xbox method. 4 times negative 1 is negative 4, just to see if there are any numbers that I can go ahead and, or any way that I can factor this trinomial, right? So then I can say that the front term is 4x cubed. The two terms are 4x squared y and negative x squared y. And then the last term is just negative 1. So then I can say that this is 2x and 2x squared or, my bad, or actually, no, I'm right. 2x and 2x squared. And then I can say that -1 times 2x squared is this one. Now, oh Lord, there's a problem with this one here, right? Because obviously I really don't know, and I'm gonna go ahead and look at this myself because I really don't know if this is factorable. Okay, so interestingly enough, this cannot be factored any further. So in reality, this as, you know, basically factored would be, it would just be this, right? We cannot factor that any further, especially this part here, this term where it says 4x cubed plus 3x squared y minus 1. I did try to factor that, and it's not possible. So this would be our answer for this one. So let's move on. Because yeah, I don't want to just keep rambling. So give me 1 second. Okay, so this is an interesting one. It says to factor this one, right? And trust me, guys, I know that this is, I mean, obviously we do not like fractional powers, but once you get to calculus, you are going to use these so often when you do derivatives of, basically when you have x to the 1/2 and then you just do like 1/2 x to the 1/2 minus 1 power, etc. But that is beside the point when you do derivatives. But this is why they teach you how to do these, so that way when you do more derivatives where you have something like, you know, something like this, and they're asking you to take the derivative and etc. That's why they teach you how to factor using these, so that way you know how to factor with fractional exponents. Okay, so this one is very interesting. Now, I do believe that you can use, how do I say this, like the square root form, but, or the radical form, but at the same time, we have to kind of also understand how to factor out a fractional exponent when we're given an expression with a fractional exponent. So let's say, if we want to factor this, you always go for the lowest term. You want to say x to the 1/2. It's like if I say x to the 6th plus x to the 5th. Well, I always go with the lowest term. This is just x to the 5th times x plus 1, right? Similarly, I look at the lowest term. I say x to the 1/2 times x, and then I say what's 1/2? So 1/2 plus something will give me 3/2. What is that going to be? Well, that's just 2/2, or it's 1, right? So it would be x to the 1/2 times x plus 1, right? So that's what we're doing here, except here we can factor out a 3, if you think about it. So we have 3 times x to the 1/2 minus 3x to the 1/2 plus 2x to the negative 1/2. Now, here we can say the lowest one that we can take out is negative 1/2, right? So if we say 3x, so 3 times x to the 1/2 times, and then I can say 1 minus 3 plus, and then I can say this is, how do I say it? 2, it would be, what would it be? It would be, would it be 2, give me 1 second, guys, hold on. It would be 2x to the negative 1, right? If you think about it, because when we multiply this out, we get 3x to the 1/2, and then we have 1 minus 3 plus 2x to the negative 1. That's just 3x to the 1/2 times negative 2 plus 2x to the negative 1. So then that gives us 3x to the 1/2 times negative 2 times the quantity 1 minus 2x to the negative 1. And then I can say that this is equal to negative 6x to the 1/2, because these two get multiplied together, and then times 1 minus 2x to the negative 1. Now, obviously, I mean, this is how it would be. I don't know exactly how else they would do something like this. I see, okay. Yeah, this one's pretty weird. I mean, I guess I don't fully understand how they would do something like this. Now, in reality, this is supposed to be 3/2. I think that's why I got it wrong. Give me 1 second, guys. I'm so sorry. Okay, so, the way that this one is, and I know this is taking a little longer than usual, you want to make sure you do it, and like I said in this, I said it over here when I said you want to take the lowest term, right? However, one of the things that I want to emphasize is the fact that you want to make sure that when you factor out this and you put the terms in, you want to put it in fractional exponents first, so that you know exactly, so that you can make sure that yes, when you multiply it in, it gives you this result, right? So you have to be careful. This is a tricky problem. That's why it's taking me a while to do it, or a little bit longer, but we have 3x to the negative 1/2 times, and then it would be so x to the 4/2, that's just x squared, minus, and then 3x to the 2/2, that's 3x, right? And then plus 2. So, now we go ahead and factor this, right? X squared plus minus 3x plus 2, that's just negative 1 and negative 2, so it's going to be 3x to the negative 1/2 times x minus 1 times x minus 2. Okay, it's a tricky problem. I had to look at it myself, so this is what they did. Okay, so this is factored out 3x to the negative 1/2, and then factor the quadratic, but they simplify it they go very fast in this. They don't tell you how it goes step by step like I do. That's why I'm explaining it as thoroughly as I can. So let's do part B. This one's another hard one, but let me try to actually explain this as best I can. So give me 1 second. Meanwhile, I actually explain this. So give me 1 second. Okay, so looking at this, right? Of course, you would want to try and factor out. So basically, factor out the lowest term, right? In that case, it would be -2/3, right? Now, this right here goes with this one. Just because we have this exponent here in between 2 plus x and x, this is not correlated with x. These two are different terms. This is a term in and of itself, and it's being multiplied by x to the first. So do not get confused. That's the only thing I wanted to mention, and so basically, we're gonna go ahead and factor out we're gonna try to factor out this, and then, so basically we're gonna say 2 plus x to the -2/3 times, and then we're gonna say x plus the quantity, and it's gonna be 2 plus x raised to the, and it's going to be, how much would it be? It would be 3/3. That's what it would be, right? So then, since we are factoring this out, so we're factoring this, right? And this is what we get when we factor out the 2 plus x, right? Now you have to be careful because you have to use grouping here. So, how do I explain this? This is a little tricky for me because it's been a while since I've done these, and give me just a few seconds, guys. Okay, so the way you can do this one now is, so now that you kind of factored out the 2 plus x out of both of these terms, right? You factored out a 2 plus x. So look at this part here, right? We're going to look at this part. Specifically the right part of this. So this 2 plus x to the 3/3, right? We can simplify that. We can say that this is 2 plus x to the -2/3 times x plus, and then 2 plus x to the 3/3 is just 2 plus x, right? Now, think about it. This is to the first term, so really we don't need these parentheses here. We can say 2 plus x raised to the -2/3 times x plus 2, right? And that means we're going to have 2 plus x to the -2/3. X plus x is 2x, and then we have a plus 2 left over. Now, we can factor this. We can factor a 2 out of this, and we can say that this is 2 plus x raised to the -2/3 times 2 times the quantity x plus 1. So then we have the following factored form. It can be 2 times x plus 1 times the quantity 2 plus x raised to the -2/3 power. This is the final factored form. Okay, this one's tricky. These two were very tricky, okay? And the reason why they want us to know how to do that is because in calculus, it's very important that we know how to do this, right? So, of course, we can go ahead and check by using the laws of exponents. We can multiply it back in to make sure that we've factored it correctly. Now, there's also factoring by grouping. Factoring by grouping is another thing. So if I have x cubed, so for example, x cubed plus x squared plus 4x plus 4, I can say the following. So let's do the following, right? Let's go ahead and turn these into an addition of two functions, right? Or an addition of two, the addition of two factors. So we have x cubed plus x squared plus 4x plus 4, right? This can be x squared times x plus 1 plus, and then we can factor this, we can say 4 times x plus 1. So look at how they have a common factor of x plus 1. That means that we can grab this, and then we can also grab this. However, do not repeat these two, because really, if basically this is going to be x squared plus 4 times x plus 1, you only do this once, really. So in reality, you can say that this equals x plus 1 times x squared plus 4, because if you go ahead and do distributive property, this is going to give you x squared times x plus 1 plus 4 times x plus 1, which is exactly what we got. Think of it as distributive property, where a equals x plus 1 and b is x squared and c is 4. So it's like a times b plus c, right? That's how you want to look at it. That's why it's this equals this, right? This is called grouping. Factoring by grouping. Okay. Okay, guys, so that concludes this section. I know that I did go a little bit, I tried going faster than usual. I did not want to make this video really long, but sometimes explaining this is not, like, it's not very straightforward. Sometimes I can't explain it as fast as I want to, and I know, I did try to go as fast as I could. But like I said, if there's anything that, or if there's anybody that has any questions, you can always comment down below, and I can try to answer it to the best of my abilities. I did not go over the exercises in this section because everything that's on here, I just wanted to kind of teach it in my own way. We're gonna just do one more, okay? And that'll be it for this video. So let's do this one here. X to the 5th y squared minus xy to the 6th, right? And then that'll be it for this video, because I don't want to make it really long, or longer than it already is. So let's go ahead and just do it very quickly. X to the 5th y squared minus xy to the 6th. So again, you can factor out an x, so you can say x times x to the 4th y squared minus y to the 6th, and then you can factor out a y squared. You always want to look at the smallest number, right? You can say xy squared times x to the 4th minus y to the fourth. And notice that you can use the, anytime you have x to the a minus y to the a, you can use like basically any, you can use this form, right? So because this one is really x to the fourth minus y to the fourth, we can say, or actually, hold on. It would be, so what I'm trying to say here is, anytime you have anything like this, if the number is even, you can do, so just like we did x squared minus y squared equals x plus y times x minus y. And I don't know how else to explain this. If anybody can explain better, it would be great. But this is just x squared quantity squared minus y squared quantity squared. And now we have it of that form, right? So we can say a squared minus b squared equals a plus b times a minus b. So we can say that this is equal to x squared plus y squared, right? Because in reality, a equals x squared, b is y squared, and this is equal to x squared plus y squared times x squared minus y squared. And we can actually factor this out with the difference of two squares pattern. You can say x squared plus y squared times x minus y times x plus y. Okay. So in reality, this simplifies to xy squared times x squared plus y squared times x minus y times x plus y. Okay. And I believe that's the answer, if I'm correct. Yes. So this would be your answer, okay? Okay, guys, I think that's enough for this video. I don't want to make it longer than it is anymore. If you guys have any questions over this section, please do let me know. I went as fast as I could. And like I said, it says this type of factoring occurs in calculus, right? I said this because I didn't have to read this part. I know it does because I've taken Cal 1. They do this kind of factoring in Cal 1 when they do derivatives, okay? So, so with that being said, guys, I hope this helps, and if you have any questions, please let me know, and I will see you guys in the next video. Bye, guys.